other panelists, can you confirm that you can see my screen?
Yes.
Yes.
I can see it.
Thank you. All right. Good afternoon, ladies and gentlemen. I would like to thank you for the opportunity for today's conference. Today, I will present our paper titled Forecasting COVID-19 Total Daily Cases in Indonesia Using LSTM Network. My name is Clarissa, and I'll be today's main presenter with my co-author, Ms. Claudia Rachel Wijaya and Ms. Nunung Nurul, and we are from Bina Nusantara International University, Faculty of Computer Science, Jakarta, Indonesia. Today's agenda will start with discussing the background, which includes the origin and background knowledge of COVID-19 itself, moving on to the methodology on how we achieve a forecast of COVID-19 cases, followed by result and the forecasting of COVID-19 cases, and lastly, I will conclude the presentation. So without further ado, let's move on to the background. So by now, we are all familiar with the coronavirus or COVID-19 diseases, which is an infectious disease that can spread through particles. So if you look at the very brief timeline here, the COVID-19 itself happened in December 31, 2019, with mysterious pneumonia disease infecting dozens of people in China. And in January 11, 2020, China reported its first novel coronavirus death. And in the following 2 months, which is March 3, 2020, the first confirmed case of COVID-19 entered Indonesia. And as of January 9, 2022, the time that we built the deep learning model, there are 298,915,721 confirmed COVID-19 cases worldwide. However, I believe that by today, the total has definitely spiked to around 450 million confirmed cases worldwide due to the rise of the new variant, which is the Omicron variant in the previous month. Moreover, frequent display symptoms of COVID-19 includes fever, coughing, sore throat, shortness of breath, headaches, nausea, and diarrhea. And they may often be accompanied by fatigue and anosmia, with the level of symptoms varying depending on the age, previous medical issues, and so on. So for COVID-19 safety precaution, here are some of the methods the government of Indonesia has applied. First is travel restriction during major holiday, such as Christmas and New Year as of the latest one. Second is the increased vaccine quota and administration, which in the previous month, the government has pushed booster vaccination shots distribution. And lastly, we have Peduli Lindungi application, which is an official government digital contact tracing application to prevent the spread of COVID-19. And this utilizes the citizen participation to share their location while traveling to places for contact tracing in case they come into contact with someone who is infected with the coronavirus. So here is the problem. Due to various reasons, daily COVID-19 cases in Indonesia are delivered late by a number of days, weeks, or even more. Therefore, the daily cases we are presented with is the accumulation of the previous days or weeks reports, which causes the daily reports to be inaccurate. Our paper delivered the solution by forecasting COVID-19 total daily cases through a predictive model approach using deep learning, where we can gain insight of the total daily cases of the day, and also use this forecast for decision making, such as early intervention to the virus spread. For the deep learning technique, we determined that LSTM, long short-term memory, is the ideal technique to forecast COVID-19 cases. Since COVID-19 cases dataset are dynamic data that can have sudden drastic changes in fluctuation, LSTM can minimize the MSE error value to forecast accurately. And the input data consists of daily updated database of COVID-19 confirmed cases in Indonesia and will result in forecast of the actual number of daily COVID-19 cases in a national level. And continuing on to how we achieve those results. The daily COVID-19 case forecast begins with acquiring the data set. The study utilized a daily updated COVID-19 confirmed cases count we obtained from Johns Hopkins University Center for System Science and Engineering database. COVID-19 forecast used in this time series data is from March 2, 2020 to January 9, 2022, which is the current time we built the model. And as of the end of our time series data, which is in a span of 678 days, there are a total case of 4,266,195 COVID-19 confirmed cases in Indonesia. First of all, for dataset preparation, the COVID-19 cases dataset will be split into 80% training and 20% testing. As you can see from the graph, where the blue line indicates training data and yellow represent testing data. And furthermore, since the proposed research is a time series forecast, the data distribution have to be a time series and no random state will be added. Next, a normalization method is used in order to convert large number of cases to binary valued factors. This is necessary as the total cases of COVID-19 can be high and can have sudden fluctuation. And the method we use for this paper is min-max scalar. With the results showed in the following table. As you can see, the table on the left is the original dataset, and on the right is the dataset after normalization. For the architecture model, we utilize the classic LSTM architecture consisting of a cell state forget gate, which is indicated in the red highlight in the image, input gate indicated by blue highlight, and output gate with yellow highlight. And for this research, we utilize Keras open source software library to form the LSTM, where the Keras model configuration is listed here. The first LSTM layer consists of 128 internal units, and the second LSTM layer consists of 64 internal units. 2 dropouts are added to the model to prevent from overfitting by randomly dropping the edges from the hidden unit. Lastly, the dense layer is used to retrieve inputs from all the neurons from its previous layer, with the last dense layer generating on 1 neuron. So after the model has been trained, a variety of evaluation metrics are used to analyze the model's results and performance. The 3 metrics we use includes mean square error, MSE, root mean square error, RMSE, and mean absolute error, MAE. And with the indication that a low value from the 3 evaluation metric means that the forecast will be more accurate and the better it will be. Moving on to the result and forecast. So first of all, model evaluation plays an integral part in our research. Forecasting COVID-19 total daily case requires the most accurate prediction the best model has to offer. So after the process data is trained using LSTM model I mentioned earlier, a model evaluation method is used to determine the best model from multiple different hyperparameter set. So in this research, the hyperparameters configured and adjusted include the number of epoch, batch size, and the look-back period for the LSTM model. So firstly, the varying number of epochs are tested in the LSTM model. The first LSTM model is tested with batch size of 8 and 5 look-back, which will be adjusted also after resection in order to formulate the best result. From our finding listed in the table, it can be concluded that higher number of epoch will result in worse evaluation metric scores. This is due to overfitting, where the model is memorizing training data instead of learning the data more generally. So to conclude, the best results is in 50 epoch. Thus, continuing the experiment, we will implement 50 epoch to the LSTM model. Next, the batch size hyperparameter is experimented with 5 lookback and 50 epoch. The batch size defines the number of samples to work through before updating the internal model parameters, which is a crucial implementation to receive the best performance. And according to our finding, batch size of 8 produced the best average of evaluation metrics. Lastly, look-back LSTM, which are custom inputs that enable the model to easily recognize pattern across the designated time period from the look-back number. So in this research, the time period unit is in number of days, since the input consists of total daily cases of COVID-19 in Indonesia. So the results show that the best look-back period is 10, meaning that when determining the total cases of COVID-19, the most significance lies in the total number of cases from the 10 days ago. So after hyperparameters optimization, the final loss values for each evaluation metric score can be determined, where this showcased the graph for each evaluation metrics values, MSE, RMSE, and MAE, for optimized hyperparameters with 50 epoch, 8 batch size, and 10 lookback periods. So here is the result of our testing data. The actual confirmed cases is the yellow line, as you can see from the graph, are then compared to the prediction of the LSTM model made from September 2021 until February 2022, which is indicated in the green line. As shown in September, the model predicted a lower number than the actual number, but started predicting a higher number than the actual number at the end of December 2021. Then afterward, we forecasted to the next 7 days. So as shown here in a more close-up look of the graph from our testing dataset, where our model predicts a significant increase in COVID-19 cases on the month of February. So to wrap this up, from our experiment, our model works best at 50 epoch batch size of 8 and 10 lookbacks. There are some limitations to the study that should be mentioned and that we can improve on our future work. First of all, this model is univariate, meaning that some factors were not considered. And since COVID-19 has many factors that contribute to the fluctuation itself, such as government precaution that I mentioned, and new variants of COVID-19, and so on. So if multivariate datasets are available, that could affect the prediction of the model, which could possibly improve the accuracy of the model. Lastly, experimenting with different kinds of LSTM models to find which is best is a recommended method for our future studies. And here are the references we utilize for our research. So that is all for my presentation. Thank you.